We'll take a quick look at the triangle congruence theorems. So this, unlike the similarity situation, we want congruent. We want the angles to be congruent, and the sides are going to be congruent. So before we had proportional sides, now we have congruent sides. So if you remember, there are 5 of those. There's side, 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 angle, side, angle, angle, side, and then the one that was kind of off by itself was HL. And remember HL, the best way to see that, you need a right angle, and you needed to spell, you needed that bad word, so you needed to either uh, spell it forwards or backwards, but you had to have the right angle and the bad word. That indicated HL. So we'll look at a couple quick examples. So you see the side, side, side is marked, the side, and the side. So these are congruent by side, side, side. Here you can mark the vertical angles. So now we have an S, an S, and an A, an S, an S, and an A. But here we go with a bad word written backwards, right? This is not, just as a heads up, SAS, because the angle would have to be between the sides, and we don't have this particular angle marked. So we're not at SAS because the angle's in the wrong place. So what we do have is SSA. There's no right angle, so it's not HL, which means these are not congruent. All right, we'll look at number 22, where we can mark some vertical angles again, but this time we have an angle, a side, and an angle on the left triangle, angle, a side, and an angle on the right triangle. So these are congruent by ASA. Remember, you want the same thing in both triangles. 23 reminds us that there's a shared side, so we can mark that. And so we go ASA on the top triangle, and on the bottom, ASA, which means these are congruent by ASA. Here, mark a vertical angle again. Then we go S, angle, angle, side, angle, angle, which means these are congruent by SAA or AAS. Either one of those, it's really saying the same thing. And then in 25, we mark a vertical angle, so we have an S and an A in the top triangle, an S and an A in the bottom triangle, but we don't have enough information. SA isn't one of our theorems, so right here, these again are not congruent. Bottom part of this page reminds us about the midsegment. Remember, the midsegment is a lot like what it sounds like. It's something that's in the middle of a triangle. So it's a segment that joins or connects opposite midpoints. So if we look at our picture just below, the midsegment will be MN. Right, there's our midsegment. But what happens, M is a midpoint, so KM and ML are congruent. Then N is a midpoint, JN and NL are congruent. So a couple quick examples with it. If MN is the midsegment, find the length of MN if KJ is 16. Well, the midsegment is half the length, which we see right here. And that tells us then that MN equals 8. 8 is half of 16. All right. We'll use the same picture for the next problem. Find the length of KJ if MN is 22. So here, instead of cutting it in half, we need to double it. So here, KJ be equal to 2 times 22, which is 44. Right? And then one more example. This one's probably a little bit more applicable and something you should make sure you can do. If MN is 2x plus 1, and then KJ is 3x, the mistake a lot of people would make would be just to set these two things equal. Well, that's the issue. They're not equal because, as you see in the second rule up here that I'm putting a star on, the midsegment is half the length. So in other words, we need 2 of these to equal the base. So we got a very easy way to do that. So we need 2 times 2x plus 1. And make sure you put that 2 outside the parentheses, because now we can do our distribution. We end up with 3x equals 4x plus 2. Here, we can't do anything with that 2, but we can move the 4x over. So we subtract 4x, and 3x minus 4x is negative x equals 2. And so if negative x equals 2, then positive x equals negative 2. And that does seem a little bit strange. We have a negative value. So my recommendation to you, as you're looking at this, just make sure that we go back and you could plug it in if you feel a little bit skeptical. That's a negative number, I'm not sure. So KJ would be 3 times x, so 3 times negative 2. And MN equals 2 times negative 2 plus 1. So 3 times negative 2 is negative 6. Negative 2 times 2 is negative 4 plus 1 is negative 3, and sure enough, kj is twice as big, right? Negative 6 is twice as big as negative 3, so everything's okay. And then the final blank, we didn't use it here, but the midsegment and the base are also parallel to each other. So we could use some of the parallel stuff that we talked about yesterday.